charging the family water. So we have, for the jet, we have for payments, and then we have for gasoline, gas oil, and so that's the infrastructure that I will, put it all the way here. And then the other one also is geared up to go to the tank farm where we have the product. So you can see from our product tank, the ship is over it's about 40 kilometers. But here, you can discharge any ship, and now the ship you discharge to 1.3 million barrels. That's the real ship. Yes. So, but normally all those who are bringing from US, they are bringing 2 million barrels. Yes. But it's just that in Nigeria, the facilities of loading, they are still low. They haven't changed. It's at all facilities. So they can do only a million. Yes. And our own thinking, next step is for us to actually get our own ship. I think something that we will look at today. Yes, because yes, I mean sometimes, especially when we have the case, then we have to now go quickly and look for what is the market. And you can see 18 hours journey, they will charge you $2.2 million. Because they are waiting. It's a reason that people are used to making money. So they are waiting. And they know that some people will come. So they wait and charge. Yes, that is our own picture. Yes, do you have any sheep?
Yes, sir. Yes, sir. We have.
Okay, he's captain.
Good afternoon, ladies and gentlemen. My name is Captain Rana. Under largest leadership, I'm looking after the marine operations. So I'll point you to the SPM where we have a tanker right now. This is the SPM boy there. Our product number, PMS and one EGO. Very heavy. So what we have here is offshore terminal with 5 SPMs. SPMs are single pond mooring buoys, 2 for crude and 3 for products. The crude oil SPMs can take in world's largest tankers, the ULCCs. One ship which came in here brought 3 million barrels. One ship itself. That is twice the Nigeria's production per day. Then we regularly get ships bringing in 2 million barrels, one ship. And very routine is 1 million barrel Suezmax tankers. Then the product SPMs are also designed to bring in a very large tankers, up to 160,000 deadweight tankers. But product tankers normally they carry smaller quantities. But our design specification is to handle larger ships and very fast turnaround. Ships calling it our SPMs typically finish in 24 hours. So far, we have done 800 tanker calls in a short period of time, and we are projecting going to 600 tanker calls per year. The reason we chose offshore is, of course, because we get natural depths, and these tankers come with very large depths. VLCCs coming is 22 meters draft. Then we need a UKC under key clearance. So that area gives us natural depths, very stable, without any maintenance dredging required. Bringing in the harbor here for deep tankers would be very, very expensive to maintain. These SPMs are world-renowned, very robust technology used worldwide. My previous employment was in ADNOC, Abu Dhabi. Yeah. This one is a Houston-based company, Sofit, US-based company. The telemetry system is from UK. They are also the world leaders in this market. Our control room over there, we can control the SPMs
This way and that, yeah. So that's the control.
So from there, we can control the walls at the SPM. We can get,
You know, we have to go. Yes, control.
then we can also see the data, pressure, temperature, the mooring house, the loads, all that can be seen there. Then of course the communication channels, all that is existing. We closely liaise with NPA, Nigerian Navy and other authorities, control the operations, talk to the refinery team, and the operations are done day in, day out.
So the SDM, do you have any concerns around security?
Well, this area is calm, but we do take precautions. We have our own two security patrol boats, 24 by 7 coverage. We get support from the Navy, Nevasa. Yes, yes.
Yeah.
Yeah, so we have multi-layer coverage for this area.
You can see, road.
Yes.
So you can see here, we haven't tested here yet. And this one now,
Which in terms of ocean engineering is an achievement. They are bedded into the seabed about 2 meters below the bottom. The trench and close to the SPM they rise, then the phlegm and the buoy hoses, and through the floating hoses, ships are connected for the transport. Yes, sir. Let's go to the port.
no, this is our one.
We can see with you for what? What?
Yes, sir. Ladies and gentlemen, again welcome to our private harbor, Dangote Keys. What you yes, so what you see here is started as a humble jetty for project cargoes. Then it was developed to bring in a high load-bearing jetty to construct the refinery. So a lot of heavy cargoes coming through Apapa could not be handled. So the load bearing there was 2.5 tons per meter square. This was built to handle 10 times that, 25 tons per meter square. The civil engineers who saw the cross section diagram, they say it is probably even 50 tons, but officially 25 tons we say. And thereafter, the entire refinery was built through the project cargoes coming through this. One piece of cargo was 3,000 tons. In massive terms, if you see the ship is about 9,000 tons. So 1/3 of this ship completely lifted, put on the jetty. Then further on, this harbor was extended to bring in urea vessels. This current vessel you see is loading for Brazil, 32,000 tons of granular urea. Brazil.
Ukraine.
Yes. Our primary.
My majority before our market was US. So it disrupted this duty stuff. And it was giving Russia zero duty, then 82. But then now the farmers are in their complaint, so we are so we UK,
UK too.
Europe.
UK, Europe, and now Ethiopia is picking up a lot of parcels. 70% approx they want to take out.
Actually, yeah, Ethiopia now will be taking 70% of the production because we have a contract with them now. So we start supplying. They've given us gas. They given us gas. You know, $2.20 for 10 years. And then we have also sold the other blend for 10 years. But And you know, like what we did, that's what I was saying that NNPC needs to look at something like that. So what we did now was rather than us to listen, let's partner with them. And so we partner with them now. We own 40%, we own 60%. Yes.
So as we are expanding our urea plant from current 3 million tons per year to 9 million tons per year, that will make it the world's largest fertilizer plant. And then the loading process would be through a conveyor system coming from the fertilizer directly to the jetty. Currently is through the tippers. They bring in about 30 tons per truck and they unload on a ship loader and then to conveyor onto the ship. In future will be a conveyor system. And then to cater to the enhanced production, we're going to extend the harbor. The process is already underway right now. Slightly bigger than the ships, 4 vessels will come on the northern side. And we are planning 4 tanker jetties on this breakwater. This breakwater, sand breakwater, will be shifted out a bit, and 4 tanker jetties to cater to LPG, gasoline, gas oil, and jet. Probably fuel oil as well, and maybe another grade. We will be able to bring in tankers up to 250 meters long, which is about 100,000 tons dead weight, and to any smaller size vessel to cater to domestic cargo. The fuel oil barges may also want to come and take, making Nigeria as the bunkering hub, which currently is taken over by Lome. Then this harbor right now is at 9 meters depth. We load up to 33,000 tons per ship. As our design is for 14.5, we expand, go to 14.5. We'll be able to load 60,000 tons per vessel on the urea vessel. And the tankers coming in would be up to 100,000 dead weight. And 10,000 is the bottom side.
So already you have built the key to take up to 14.5 meters draft. And right now, if you look at it, we are even losing money because areas where we need to be competitive is to load a ship that's big, so that we don't pay dead freight. So now we're giving that contract, which we are now going to dredge. Now we're opening here, dredge up to another 14 kilometers of the channel, so that we'll be able to do something like 60,000 tons. Yeah, so 60,000 tons will be very, very low on freight outcome with any market and come. But the whole thing is how to take somebody's market. Because if I'm not satisfying the market, somebody else is going to build there. So that's why when you build capacity and scale, you dominate everywhere. Yes.
And the breakwater that you stand here, just for a point of thought, is the one and only sand breakwater in the world. Any harbor or a port requires a breakwater to create a tranquil atmosphere inside. So this is the only breakwater in the world which is made of sand. So our leadership advised the Dutch engineers who are building the harbor that can you do the hydraulics, and then they came out that yes, theoretically it's possible. They built it and it is proven successful. So now
it's only sand that there's no rocks.
There's no rock here.
Interesting.
Yes. And now European universities are studying this as a chapter to implement this into future port projects. Why? Because this is most sustainable way of building a port. 1/3 the cost, 1/3 the time to build, and only 10% the carbon footprint. So it's definitely
in terms of you have a summary. What's the main thing? Is it compaction that is different? Is compaction?
Yes, absolutely. Okay. You got the point. Yes, it is compaction. So the sand quality would matter, but the way you dump it as well requires engineering precision. So compaction was ensured. You're bang on.
It's not a normal person.
Very interesting. Very interesting.
And there is the RFCC Catalyst Activity Audit.
After that, first of all, it will be fractionated to know better than anybody. Then gases will be.
I know you say, come and see this one.
Yeah. This gas will be divided into two parts. One is non-compressible, which will be taken as a coal gas, and other is that compressible, C3C4. We are converting into an LPG, and these are the naphtha. We are having a battery of the plant at one place, say before like so that we can create any octane number which is required. And then these are the different EMS grades. It is 06, 03, 04, 05. Octane wise, we are having capability to produce even a 100 octane, octane and 96 plus. We can provide a fuel for the racing car and other extraordinary events.
You said Euro 6. I didn't know you had the capacity to go.
Oh, we have.
Yeah, yes, sir. Sorry to say, yeah.
I thought Euro 5.
No, wait,
Euro 6.
we have that when
There is no basic.
we touch even 90, I mean, was stabilizing at 98 octane.
98.
Yes, so we reach even up to 100.
Sir, for that, we
We
are
put
having.
alkylation, you know that, so
Alkylation.
that's why people, when they think the RFCC is down, when RFCC is down, the only thing that we don't produce is the polypropylene. And then we'll have more of RCO. So that's just what we do. So we lose money if it's down based on these two. But otherwise, even if like last 2 weeks, we just restarted all our CDU and they didn't work for about 20 days. They're all under maintenance. But we're still doing our 52, 53 million liters every day of PMS. That's why, so during that period, we didn't sell LPG because we are using part of the LPG to inject it into this. And now we are putting DHT, which is diesel, diesel hydro treater. So that one now will be able to convert. If there's more demand on diesel, we'll put more diesel. If there's more demand on aviation, we'll put more aviation. So we'll be switching around. And then there's also another section which we are going to put, which will, when we have by accident or whatever, crude with metals, it will remove all that metals. So like here really in the refinery, we don't have any waste. Even what I've done waste, we recycle.
Are there scenarios in the mix where you have more of, what's the next? Because I know you mix.
Yeah, it's not a straight journey, no. Because yes, very dynamic, you can change. And whatever that we do, you have a lab that will test. If you come now and say, okay, what did we dispatch on December 20th last year? You just go and punch the computer, it will give. And then the result comes out automatically. You just put the product, it gives you the result. Not that you go and, play with it. People buy, no, seriously, people buy certificates.
I know,
yeah, $10,000 a piece.
Thank you. Very interesting. Thank you.
Here in Law, we test and assess the quality of petroleum products. So, and in analyzing this
petroleum product quality. We use several instruments. Let's start from here. This is the auto titrator. It is also it is used for titrating the acids, like it is used in analyzing the acids in the petroleum products.
So that there's no testing.
Yeah, understood. So, now, this instrument is used for measuring the freezing point of petroleum products. Ground point for also lighter petroleum products. Example is the ATF, the aviation turbine fuels and kerosene also. Then this is the copper corrosion gauge. It is also it is used for measuring the corrosiveness of petroleum products. You know, most tank storage is made of copper metal, so we have to analyze if this petroleum product is very corrosive to the metal. So it aids the storage of.
That is very big.
So now this is the first point. Like first point is this tester is used in analyzing petroleum products by measuring the flash point. So what it basically does is it measures the minimum temperature at which the petroleum products can ignite in presence of oxygen. So if it has very low flash point, it means at very minimal temperature it ignites.
You know what we used to do also, the flash point depends on when you put it in. We used to do before was to go to filling stations and buy, and when you come here you test, you see that it's way low. So yes, you are buying liter, but it's not a liter because it burns faster. But our own here now we have, including for racing cars, where we can show you the lab, where we can now test. We actually have the engine. It's only the radiator and the gearbox.
Okay, now moving on to this equipment, this is the viscometer. It is used in measuring the kinematic viscosity of our petroleum product here. The higher the viscosity, I mean, it tells us how our petroleum product flows in optimum temperature.
We have to just work. If we are going, we have a testing.
We also have some textures and shapes in alternative.
So once we're done with our samples, we keep them here for research. And so this is our weight balance. Then the set of check for acidity. Then this is our MSCB. Then this is our particle counter. Then this is also the smoke point. This is the manual automatic. Then this is our spectrophotometer. We check for the absorbance of the sample from the light. And this is for luminosity. So all these are, and this is our data. Then this also is our flash point. So basically, we analyze ATM and kerosene.
Thank you.
Here is the fuel, the way the fuel used to be burned, more especially for the run when it is the motor is moving fastly, while for the one when it is going on a hill. So this is where we take both for the gasoline oil. So we usually test the burning efficiency of our products.
What that
So this
means
is like
is
a
that-
car, right?
So now what we can do is that you can give us a kind of product you want us to produce. And yes, because let's say there are racing vehicles that they take different values. We'll use this one to measure. Because they will write you what they need.
Okay.
For racing cars, it's not the same that you go and buy a car.
So they give you the
They
specifications.
give you the specification.
Okay.
So now, majority before when we buy from the filling stations, before we started, they were all failing that test. Because there's no mechanism, the regulator doesn't have anything to test. Yes.
Do the machines tell you the fuel will cause a cut of
It is telling you internal anti-knocking characteristic of your
anti-knocking?
anti-knocking. This one is a condition can be changed, say compression pressure, engine speed, where in this case one, it is standard one. And all over the world it is standard.
Actually, President of Ghana was trying to ask us to help test this because 3 of his series they knocked.
Wow.
New ones. 3 of his Mercedes, they knocked. Yes. That's why, when you have a brand new, like all these high-tech vehicles, when you are driving, it will tell you to go to the garage or to the,
Yeah, because of
yeah,
the fuel.
because the fuel that they are taking is not that standard.
You have to actually import your friend for those of you that like those those high-end cars. When you buy now your first car, you better buy the fuel.
If you need more gas,
And CD. That's why we took down the CD. So now we have taken everything, and that's why we have now. When they realize that look, this thing is real now. 650,
Where's that
661, 600.
Come on, can you come here?
Yeah, 661.
I want. Where's your phone?
Yeah.
Where's your? I'm serious. Bring out your phone, please. Stay here and snap straight.
So you can see now, for example, the Penex, since we are not really copying any, but most of the equipment here are designed for us. So, they will perform the minimum. But you can see here now the NHT is 163%. Yeah, you can see the Penex is 146%. RGDU is 126%. MSC, which is mainly for the diesel, is 120%. And this one we have not really pushed. They are still pushing. We are still stabilizing. We are
Very auspicious time. And also to come into
Hold on, please.
and to lead a project like this. And put Nigeria on the global map. First of all, so what's your impression, structurally, what you see on the ground?
So I think, first of all, again, I will repeat that Nigerians, we should be grateful for the leadership and the inspiration of Alhaji Dangote and the Dangote Group for what my colleague called the audacity to embark on such a huge project. And what I will also say, secondly, is that no matter how much I have spent time, I've watched the videos of these facilities, I've watched all sorts of reports on the facilities. There's nothing like being here physically to actually see things for yourself. What we are seeing here is more I'll call the front line of world-class technology. What most people may not really appreciate sometimes when you hear things being done like this in Nigeria is that you have the opportunity to leapfrog, take the learning from all over the world, and then apply it to deliver an outstanding world-class facility like this refinery. So this refinery has benefited from all the previous learnings. So when you hear a single train, the largest single train in the world, if you're not familiar with the details, you'll be very worried. And everybody was worried. I was also worried, right? But coming here and seeing the architecture of the plant and the redundancy that has been built into the plant, then what you see is that the plant has been built in such a way that despite being single strain, it has an incredibly high availability. So the perception of the old designs, I'm an engineer, so I can speak to that, right? The old designs do not enjoy the level of technology that you see here. So why is this possible? Now it's clear to me that it's possible because it is taking advantage of the best of technology, both digital technology, AI technology, as far as advanced electronics and mechanical systems as well. So it's an impressive facilities. It's also important to say that I feel really proud as a Nigerian standing next to Alhaji, because this plant has not been tested to its full capacity, above its full capacity. Now what we saw on the screen today, which excited me, is at 661, right? This plant was supposed to be 650. None of us ever thought it would ever touch even 550, right? So seeing it live, and the parameters we are seeing are live parameters. They're not parameters that have been reported or photographs that have been written anywhere. I think every Nigerian should be proud that such an edifice is actually in Nigeria. Now, the next thing that also excites me is that Alhaji is not stopping there, and we as NNPC, being a very proud shareholder, and I would say even prouder today than I was yesterday, is embarking on the expansion of these facilities. And what that means is what we call replication. Replication is when you design something which is, you already know you've made all the mistakes, right? And then you just design one, build two, build three, build four. So what Alhaji has briefed us today, which excites us, is that the expansion of the plant is in hand, which means that we will double the capacity of this plant by just replicating exactly what is on ground, and then leverage.
NNPC, I think the sky is the limit, and we will cooperate and also make sure that we work together to make sure that we make Nigerians proud. The other issue is that, look, they are holding 7.25% of the shares that we have here, which is more than the shares Elon Musk has in Tesla. So, and they are holding that on behalf of Nigerians. So, but individually, Nigerians too will have an opportunity in the next, I don't know, but I think in the next maybe maximum 4 or 5 months, they will actually be option to buy their shares. And like what I promised before, people will have a choice either to get their dividend in Naira or to get their dividends in dollars, because we earn dollars.
Thank you very much.
Besides the expansion plan, is there any other significant collaboration between the NNPC and Dangote Refinery?
Yeah, definitely. That's what we are looking at. We have a block 71, 72, but we're going to look much, deeper. Most likely, depending on our own discussions with them, we will partner with them maybe in some of the upstream. They too, they will partner with us here, because here is not a refinery, it's an industrial hub. And that's why we are doing, linear alkaline benzene, which is raw material for detergent. And that raw material for detergent will be sufficient for the entire African continent. It's 400,000 tons, which we don't have. The only two is one in Algeria, 100,000 tons, and Egypt, 50,000.